about acid nomenclature today, and there are two types of acid nomenclature. And it's important to remember that these are covalent molecules, just like we talked about yesterday with the covalent molecules, because they're sharing electrons. And you're going to have binary acids, which is going to be hydrogen plus one nonmetal. And there's three rules with this, and you're always going to have a hydro prefix. So you're always going to start it with hydro. You're always going to end in ic acid. So when you write these, it's going to be hydro, the root of the nonmetal, and then it's going to end in ic acid. And then the third rule is the number of hydrogens depends on the charge of the nonmetal. So it has to cancel that out. So for an example, this is HCl. So that is hydrochloric acid. All right, and then this is H2S. So that is hydrosulfuric acid. And then the last one here is H3N, and that is hydronitric acid. So as you can see, they all begin with hydro, then they have the root of the nonmetal, then the IC ending, ic acid. The number of hydrogens depends on the charge of the nonmetal. So chlorine has a -1 charge, so it needs one hydrogen to cancel that out. Sulfur has a -2 charge, so it needs two hydrogens to cancel it out. Nitrogen has a -3 charge, so it needs three hydrogens to cancel it out. Now, if it was a carbon, it would be a -4. So you can think about it, what would that be? If it was H and C together, this is a -4, so I need 4 hydrogens. And that would be hydrocarbonic acid. Now, I will tell you, you're going to have to do the practice because the only way to get these roots down is to do the practice and check it. And they will be on Schoology. So that is binary acids. Now, you don't want to confuse those with the next one, which is ternary acids. And that is hydrogen plus a polyatomic ion. So you can remember we got the polyatomic sheet that has all of our polyatomic ions on there. And now these will never have a hydro prefix. So the only ones that have a hydro prefix are the binaries. These just start with the name of the polyatomic. So the ending is going to depend on the polyatomics ending also. So an 8 is going to become an ic acid, just like these became ic acids. And the ITE ending on the polyatomic is going to be OUS acid. And the number of hydrogens is going to depend on the charge of the polyatomic ion. So if I have HClO3, this is going to be, that ClO3, I look on my sheet, is chlorate. So that is going to become chloric acid. So notice, there's no hydro prefix. Because it was chlorate, it became chloric. And that's how you know what the ending is. This, I look on my polyatomic sheet, is chlorite, ITE. So I told you a second ago that the ITEs are going to be the OUS. So it's going to be chlorus acid. All right, and so like I said, you're going to be looking at the polyatomic ions, and that's where you're going to be getting the core of the whole name. So what if I have this? What if I have H3PO4? That comes from phosphate, so it's going to be phosphoric acid. And then if I have H3PO3, that comes from phosphite, which is going to be phosphorus acid, OUS. All right? So you just have to do the practice. And the more you practice, the better you're going to get. Okay? Now, how many hydrogens do I have? So if they give me sulfuric acid, and I have to write the formula, right away I know that it's ternary because there's no hydro prefix. So I know it's going to come from my polyatomic ions. Well, look at the ending. If it's ic, that means it came from an ATE. So that means it came from sulfate. So you look up sulfate, you know that it's SO4. You look at the charge, it's a -2. So then I need 2 hydrogens, and I'm done. So all I'm doing is adding the hydrogens to the polyatomic ion, and I'm canceling out the charge. So if they gave me nitric acid, I look on my sheet, and it's an IC ending, so it comes from nitrate, which I look on my sheet is NO3. It's a -1, so I need 1 hydrogen. So it's HNO3. So as you can see, you just have to work back and forth from your sheet so you know what you're looking at. Now, what if it gave me 3 different ones? If it gives me chlorous acid, it gives me hydrochloric acid, and it gives me chloric acid. How do I know what is what? Well, right away, we know the binary because of the hydro prefix. So I know that that's going to be hydrogen and chlorine together. Chlorine has a -1 charge, so that means I need 1 hydrogen and I'm done. Chlorous comes from an ITE polyatomic, which is chlorite. So that is ClO2, and it has a -1 charge. I looked it up on my sheet, okay, and so I only need 1 hydrogen. So that's the answer to that one. And then the last one, chloric acid, comes from chlorate, which I look up on my sheet, and that's ClO3 with a -1, so that is HClO3. So that is how you do acid nomenclature. The most important thing is you always look to see, does it have a hydro prefix? And then remember, it's going to be the hydro, the root, and ic acid for the binaries, and then the number of hydrogens depend on the charge. They got to cancel it out. For the ternaries, it never has a hydro prefix. And its ending depends on the polyatomics ending. If it's an ATE, ic, if it's an ITE, OUS. All right, hopefully you get the practice done and get after it.